are now looking at section 3.5, and we were talking about exponential and logarithmic models. There's 5 basic types, and let's take a look at the first example. Is this one on your gift? Population P of a city is given by P equals 95,300 e to the 0.055 t, where t equals 0 represents 1996. According to this model, when did the population reach 150,000? So what would we do to solve this problem? Jessica. Where are we going to put the 150,000? Are we looking at number 1? On your new gift. Some help for Jessica. Some help for Jessica. Where are we going to put the... All right, 150,000 is going to go in for the P value here. So we're going to have 150,000 equals 95,300 e to the 0.055 t. Do you feel confident that you will be able to solve this on your own? All right. You're going to divide by 95,300, rewrite it in logarithmic form, and so on. Let's take a look at the situation where you are not given the growth model. So let's take a look at this example. In a research experiment, is this your number 2? Let's actually do your number 2. All right, now let's do this one. Well, all right, since you guys don't have much time, I'll say, okay, we'll go to number 2 instead of doing 1 and then having you do this. All right, so in a research experiment, a population of fruit flies, that should say is increasing according to the law of exponential growth. After 2 days, there are 125 flies. After 4 days, there are 350 flies. So how many will there be in 6 days? So in this case, you're going to use that exponential growth model. Where is it? That's this one. So we want to write y equals a times e raised to the bx for this problem. So y equals a times e raised to the bx. I just want you to understand that we need to find a and b. Those are the constants associated with this particular lab study, okay? So we're going to need to find a and b, but all we know is some ordered pairs. We know that when x is what, y is what? All right, and when x is 4, y is 350. So we have 2 ordered pairs that we can plug in for x and y. So let's plug in the first one. We would have 125 equals a times e to the b times 2. Would you agree? So we have 125 equals a times e to the 2b. If I rewrite it like this, that's great, but we are not any closer now to finding the a and the b. So what I would suggest, though, is this. How about we divide both sides by e to the 2b? Sure. So then we can get a by itself, and we get an expression. We get an expression for a, which is 125 over e to the 2b. I'm going to kind of put that in a little box so we don't lose that. That's an expression for a in terms of b. And now we're going to use our other ordered pair, right? And so I'm going to write what new equation? 350. Hands, please. Angelo.
350 equals a times e to the b times 4.
Do people agree with that? All right, and really that means I've got 350 equals, can I plug in this expression right here for my a?
Yeah.
So I'm going to write 350 equals 125 over e to the 2b times e to the 4b. Agreed? So can I divide these e to the 4b divided by e to the 2b?
Equals
If I'm dividing two numbers with the same base, what do I need to do with their exponents?
subtract.
Subtract. So I really want 125 times e to the 4b minus 2b, correct? Because if I'm dividing two numbers with the same base, I subtract their exponents. So I have 350 equals 125 e to the 2b. How will we go about solving for b?
So E
What?
to
What?
E
So I got to do what to both sides?
divided by 125.
So if I divide by 125, I get what decimal? What is 350?
14 over 5.
All right. Fractions are fine. 14 over 5 equals e to the 2b.
Put it in natural logarithmic form.
All right, so this is going to be log to the base e of what?
Well, I just put it ln.
I'm with you. I like to one step behind. ln
Of 14/15.
14. Is it 14/15ths or 14/5ths? 14/5ths equals 2b. And so let's get a decimal for this. Let's get a, you know.
B equals 1.029.
1.029, is that ln of 14/5ths? And now I'm going to divide both sides by 2. So I get b equals what?
So that's 0.515.
Do people agree with that? Can I have some independent confirmation? Yes? Is this okay? You're working this out on your calculators? Not at all. I just don't have the answers in front of me. Are you sure? Are we trusting Angelo on this one? All right, at this point, if we know our constant b, we can plug it in right here and solve for a. Would you do that, please? So we get a equals 125 over e raised to the 2 times, what was it, 0.515? Yes?
Well, wouldn't it be 2b?
Yeah, so 2
Oh, 2 times.
2 times.
Well, you could just plug in,
So give me a decimal for a. 44.6.
671.
All right, so 44.671. So I'll say 44.7. And that means our model for this function, for these fruit flies, would be y equals what?
44.7.
Remember, we're using y equals a times e to the bx. So 44.7.
E to the 0.515.
X. So here's our model. We had to do a lot of work to come up with our own model because it was not provided, but now,
Find 6 days.
right, now we're going to plug in 6. 6 days is the question mark. How many flies in 6 days? So we're going to plug in 6 right here. And when we do that, we end up with what?
982. So yeah, just 982. So you can't have a fraction of a fly.
So you're rounding to the nearest fly, and you're getting what?
982.
All right, so about 982 flies after 6 days. There is going to, I like these, hint, hint, I like these. If you don't see it on the Chapter 3 test, you're going to see it on the final exam. One or the other or both. All right, these are good problems. These are good problems. Okay, so let's take a look at number 3. But before we do, read the top of page 260. Top page 260 in your book. It says, in living organic material, the ratio of the number of radioactive carbon isotopes, that's carbon-14, to the number of non-radioactive carbon isotopes, carbon-12, is about 1 to 10 raised to the 12th power. When organic material dies, its carbon-12 content remains fixed, Whereas it's radioactive, carbon-14 begins to decay with a half-life of about 5,700 years. To estimate the age of dead organic material, scientists use the following formula, which denotes the ratio of carbon-14 to carbon-12 present at any time t in years. And the formula is R equals 1 over 10 to the 12th, e to the negative t over 8,223. That's the carbon dating model. All right, so it says estimate the age in problem number 3, estimate the age of a newly discovered fossil in which the ratio of carbon-14 to carbon-12 is 1 over 10 to the 14th. So we're going to plug in that for the R in our formula, which was R equals, what is it, 1 over 10 to the 12th? And then what is it? E to the negative over 8,223? 8,223. So if I'm going to plug in 1 over 10 to the 14th here, right? Correct? For this particular example that we're doing number 3 on your gift, correct? So I would recommend that you take this and multiply both sides by maybe 10 to the 12th to get rid of this. Multiply both sides by 10 to the 12th. So this divides out with this. And what is 10 to the 12th divided by 10 to the 14th? All right, so I got 1 over 10.
Which is really 1 over 100.
So I have 1 over 10 to the second equaling e to the negative t over 8,223. So you're saying that's really 1 over 100. And do you know what to do to solve this?
Put it in natural log form.
All right, so it's going to be written as what?
Natural log. Negative. Not negative. 1 over 100. Yeah, 1 over 100 is equal to x. So x equals negative t 8,223. And then you can,
Does that look right?
and then you solve ln of 1 over 100. Make that nice. No, don't make that nice. I'm sorry. So then it's negative 4.605 equals negative t times 8,223 divided by 8,220.
You had me and you lost me. All right, what's ln of 1 over 100? I would be having a really, do you know what? I should be like wearing this headset, then I could have like hands free, but you know, it just makes me feel like I work at McDonald's, you know. Welcome to McDonald's, can I take your order?
Boom, done.
All right, so when you did this, when you did this, you got T is approximately what? Cut me to the bottom line here. What is it? 30,000 years? Is that right? 37,000 years? Do people agree with that? All right, are we okay with this? I mean, I don't know. You guys are supposed to be checking each other on this math. Yes, we're agreeing? All right. Okay, so I think that would probably be a good place to stop. All right. So I'm going to stop this. We're going to pick up on this on Friday. So if you're not here, you're going to watch the next video installment, okay?